Alright guys, welcome in. Today we're going to be going over the gas laws worksheets, Boyle's, Charles, and the combined gas law. If you're in my 8th period today, I won't see you'll have a sub, but if you guys follow along with the video, hopefully you'll get a great idea as to how to solve these gas law problems. So the first one that we're going to go over is Boyle's law, and if you remember, Boyle's law states that P1 times V1 is going to give you P2 times V2. And we'll give meaning to that right now. But before I do, I want to go over these variables. P stands for pressure. V stands for volume. Remember, pressure can be measured in either ATM, millimeters of mercury, kilopascals, and torr. Now, this is the conversion factor for every single one of these. So 1 ATM is the same as 760 millimeters of mercury, which is the same as 101.3 kilopascals, which is the same as 760 torr. So if I have a question that says, hey, I have 760 torr, that's the same thing as having 1 ATM. Okay? Volume is usually measured in milliliters or liters. So, all right, here we go. If 22.5 liters of nitrogen at 748 millimeters of mercury are compressed to 725 millimeters of mercury at a constant temperature, what is the new volume? So let's do a quick check for understanding. Let's write our formula. So we know we're dealing with pressure and volume. So P1 V1 is equal to P2 V2. Now let's just go ahead and start writing down some of the knowns. So our first pressure, which is P1, is going to be 748 millimeters of mercury. So 748 mmHg. And then we know the first volume as well is going to be 22.5 liters. So times 22.5 liters is going to give you, we know the second pressure, which is 725 millimeters of mercury, Hg, times, well, we don't know what the new volume is going to be. So therefore, that would be X. So in this particular case, we're trying to solve for X. So this is ultimately solving like a two-step equation, I would say. So if you have 748 times 22.5 is going to give you 725X. Now, let's multiply these two here. I have my handy-dandy calculator. Let's see what we get. So we have 748 times 22.5. Yep, 22.5. That's going to give me 16,830. Sorry, 830 is equal to 725x. Now, in order to solve for x, what I do is divide both sides by 725. Divide by 725. So if I divide both sides by 725, both sides by 725, x is going to be 23.21 liters. There we go. So, and this kind of makes sense, right? And so please do not forget your liters. And so you know that if you have a lower pressure, you're going to have a higher volume. If you're going to have a higher pressure, you're going to have a lower volume because the relationship is inverse. As pressure increases, volume decreases, right? Now, let's tackle on question number 2. I'm going to try and do all of these unless my camera runs out of storage or my tablet runs out of storage, but let's try this one. So, a gas with a volume of 4 liters at a pressure of 205 kilopascals is allowed to expand to a volume of 12 liters. What is the pressure in the container if the temperature remains the same? So for this particular one, I'm going to do the same thing. P1 V1 equals P2 V2. Now, let's fill in our knowns. So we know that our first pressure is 205. So 205 times 4 liters is equal to 12 liters. 12 liters times X. 12 is our volume. X is our pressure because that's what we don't know. Now let's go ahead and solve for this real quick. All right, 205 times 4, let's see if I can do that in my head. 820 is equal to 12x. So 820 divided by 12, 820 divided by 12, that I can't do in my head. Let's pull out the old calculator. All right, 820 divided by 12 is equal to 68.3, and that is going to be kPa. Fairly simple, right? So what you're doing is you're basically taking a known substance and then you're predicting what the pressure is going to be. So scientists regularly use this to predict pressures or volumes or temperatures of certain gases if they conduct an experiment on something. So what pressure is required to compress 196 liters of air at 1 atmosphere into a cylinder whose volume is 26.0 liters? So same thing, P1 times V1 is equal to P2 times V2. Let's do our knowns. We know that pressure 1 is 1 atm times 196 is equal to, what else do they give you? They don't give you the second pressure. That's what you're trying to figure out. So that's going to be your X times 26 liters, right? So this one's fairly simple. 1 times 196 is 196 is equal to 26x. Now let's go ahead and divide that out. And we get an answer of x is equal to 7.5. 7.5. And then what is our unit of measurement? We are atmosphere, so ATM, right? And so if you were compressing air from 196 liters of volume down to 26, you would have a huge jump in pressure, right? And that makes sense. If you increase the pressure, the volume will decrease. So there's your answer. Let's see what we got. Let's keep moving. All right, now we're getting into Charles' law. And remember, Charles' law states that and so the formula for this particular one is going to be, I'm going to cross this off. It's going to be V1 divided by T1 is equal to V2 divided by T2, right? And so this is going to be the exact same situation. The units are all still the same. Pressure is still in ATM. Pressure is still in millimeters of mercury, or it can be in kPa, or it can be in torr. Now, let's figure this one out because the formula writing for this one is a little bit tricky, but I'm certain we can kind of power through. So, calculate the decrease in temperature when 6 liters at 20 degrees Celsius is compressed to 4 liters. So we have our formula is going to be V1 over T1 is equal to V2 over T2. Now let's just go ahead and fill in the blanks. Do we know our first volume? Yes, it's going to be 6. Do we know our first temperature? Yep, it's going to be 20 is equal to, do we know our first volume? Yes, our second volume. Yes, it's 4. And then do we know the temperature, the second temperature? We do not, so that's going to be our X. So when you're solving for X like this, there is a simple method, and it's called the diagonal method. So you're going to multiply 6 times X. You're going to get 6x is equal to 20 times 4, which is 80, right? And if you divide both sides by 6, so if you divide both sides by 6, you'll get your answer. And your answer is going to be 13.3 degrees Celsius, because that's what you're trying to solve for. Pretty crazy, right? And now, what's really cool about these is if you guys wanted to check your answer, all you could do is plug in the numbers. So let's go back here. I got 6 out of 20, or 6 over 20 should be equal to 4 divided by 13.3. Now, if you divide 6 over 20, that's 0.3. If you divide 4 divided by 13.3, that's going to be 0.3 as well. So that's one way you can go back and check your answers. You can actually do that for every single one of these as well. So I should have probably mentioned that at the start of the video, but I'm mentioning it now, so there you go. All right, let's keep going. So we have another one here. A container containing 5 liters of gas is collected at 100 degrees Kelvin. Kelvin is going to be a unit of measure for temperature as well. And then allowed to expand to 20 liters. What must the new temperature be in order to maintain the same pressure? Here we go. So if you have V1 over T1 is equal to V2 over T2. Let's go ahead and figure that out. So our first volume is 5 liters. Our first temperature is 100. That's going to be equal to our second volume, which is 20, and we're trying to figure out X. Let's do the diagonal cross here. So 100 times 20 is 2,000. 2,000 is equal to 5x, right? So 5x. And if we divide both sides by 5 here, we're going to get 400, I believe. Yep. 400 is equal to x, and then that unit of measurement is going to be, I'm going to drag this over here, sorry guys, it's going to be 400 Kelvin. 400 Kelvin. Alright, let's move on to number 6. If 15.0 liters of neon at 25 degrees Celsius is allowed to expand to 45 liters, what must the new temperature be to maintain constant pressure? Let's figure that out. So I'm not going to write down the formula, but we have 15 liters over 25. Please remember to place these in the correct spot. Please do not place 15 down below because that would be the temperature. So is equal to 45 liters over x. So we get x, we do diagonal cross here. And so we're going to get 15x is equal to 45 times 25. Let's go ahead and do that real quick. 45 times 25 is equal to 1,125. If you divide both sides by 15, you get x is equal to, I'm going to shift this paper over here, divided by 15, 75. And then, of course, if you guys really wanted to go back and check your answers, you could totally do it. So let's just go ahead and I'm going to set it here, and I'm going to say check answer, or checked answer. So it's kind of like your proof. 15 over 25 should be equal to 45 over x. Oh, I'm sorry, that x was 75. We just concluded it, right? And so 15 divided by 25 is 0.6. 45 divided by 75 is 0.6. Therefore, this stands true. There we go. All right. This is called the combined gas law. This is basically combining pressure, volume, and temperature with pressure, volume, and temperature again. All right, so let's go ahead and figure these out. The equation for this is here. So we're basically just filling in all of those spaces. A gas balloon has a volume of 106.0 liters. So that's our first volume right here. So we're just going to write that down. So we have 106 with a temperature of 45 degrees Celsius. So 45 degrees Celsius is the first temperature. And the pressure of 740 millimeters of mercury. So first pressure times 740. What will its volume be at 20 degrees Celsius and at 780 millimeters of mercury? So we're basically trying to figure out volume. So we don't know volume, so volume is going to be X, but we do know pressure for the second one, and that's 780. And we do know the temperature, which is 20. Now, this is going to be the exact same problem as you've done before, except you have one little extra step. You have to multiply these two first, and then you have to multiply these two first, and then you are going to cross multiply this way, multiply that way as well. All right, so if I were to figure this out, so if I do 780 times x, that's 780x times 45. So I'm going to transfer this over. So this would be 780x times 45. is equal to 740 times 106 times 20. So 740 times 106 times 20. So I'm going to pause, and then I'm going to... So once I've multiplied them out, I get 780x times 45 is going to be 35,100x. 740 times 106 times 20 is 1,568,800. If I want to isolate x, what I do is I'm going to divide both sides by 35,100. Divide both sides by 35,100, 35,100. Right? For an answer of, please hold. All right, for an answer of, I'm going to write it down here. It's going to be 44.69. So I'm going to say 44.69, or you can even say 44.7 if you wanted to. And the unit of measurement is going to be volume. That's what you're trying to figure out, and that would be liters. So L. Perfect. That concludes this particular video. What I want you guys to do is I want you guys to go ahead and you guys can skip number 8 for today. We're going to go over that one. We're going to go over what standard temperature and pressure means. But you guys can go ahead and move to question number 9, which Kelvin deals with temperature, and Kelvin is temperature as well. So this is your first temperature and second temperature. So there's your hint. Please reference this video continuously if you have any issues, and then of course I'll be back on Friday.